Hello again. Today we are taking a look at Concept 3. So Concept 3 is using tables to graph functions. Just as a heads up, we're going to be doing a lot of graphing today. Hopefully you've seen graphing in the past, but if not, you might want to take some time to really make sure that you're understanding this lesson, as we've not done any graphing so far this year in my class, but it's likely that you've seen graphing before in prior math classes. So there are many things that I've defined here. Some of them are repeats. Cartesian graph is defined here. This is just letting you know how to graph things. Okay, so we're going to get a lot of practice of this. But if you want to write down kind of the steps of graphing, you first graph the x value, then apply the y value. I'm going to go through kind of what that looks like versus this written definition is kind of maybe a little bit more challenging to understand how to graph just by reading through it. So know that we'll be doing nothing but examples today of how to graph. I'm reminding you that your input values are your x values, your output values are the y values, they're the numbers you get back out. A linear function, just remember it's a line. It has the highest exponent of the variable is 1. Every x value has its own unique y value. We've gone over a couple of definitions of linear functions prior to today's lesson. The two newest things here are vertical line and horizontal line. So you might want to take a moment to make sure that those are copied down. I have them down here on our notes page. Vertical line is an equation in the form of x equals c, where c equals a number. For example, x equals 4. So we'll talk about what makes a vertical line and what it looks like and how we can actually graph this x equals 4. A horizontal line is an equation in the form of y equals c, where c equals a number, so it's very similar, but it's y equals. So for example, you could have y equals 6. So we'll go through a couple of these as well, as they're kind of unique lines to graph. So getting into graphing functions, consider the following Cartesian graph that represents the equation y equals 3x plus 4. Okay, the word Cartesian here is just saying you have this graph with an x-axis, which is this horizontal piece, and a y-axis, something that goes up and down. So you might want to make a note in your notes here to remind you that on a graph, your x-axis is the horizontal one here, and your y-axis, there we go, is this vertical one here. And when we draw them, we usually have arrows on the ends because when we draw a graph, and even the one you see here, these graphs technically go on forever. That's why they have arrows on the end. I could continue finding more points up here if I continued the y-axis and the x-axis out. So just be mindful that we usually have arrows on the ends. It's nothing that you would be marked down for or anything like that. Just know that if you're wondering why I put arrows on the ends of mine, it's just to say that we could keep going down the x-axis or the y-axis. All right. So if we have the equation y equals 3x plus 4, what we do is we create this input-output table, this table of x and y values, and then we plot those points. And you can kind of see they're written here as an ordered pair. All right. The way that you're plotting those points is when x is -4, that means you're going to go backwards in the -4 direction on the x-axis, and its y value that it's paired with is -8. So the x-axis is horizontal, it's left and right, so the x value is going to tell you how far left or right you're going to go depending on if it's positive or negative. It's very similar to a horizontal number line. Here is 0 in the middle, and your negative values are to the left, and your positive values are to the right. And this vertical y-axis is like a vertical number line, where here's 0 in the middle, and your positive numbers are up, and your negative numbers are down. And so if your number is positive or negative, that'll tell you which direction you're going to go in. Know that these are paired numbers. So this -4 is paired with a -8. So I'm going to go back 4 to represent -4 and down 8 units to represent -8, and I'm going to plot that point there. All right, so then they went through the process again, -2, -2. So we go back 2 units because we're going -2 on the x-axis, and then down 2 units because my y value is also -2. Plotting the point 0, 4. So when x is 0, that means you're not moving in any direction, left or right on the x-axis. You're going to stay right at where x is 0. Then your y value is 4, so you're going to go up 4 units, and you get that point there. So what the textbook is doing is just walking you through how they got those y values, depending on the value of x that they plugged in. So that's the work they're kind of showing you next on that. What they're doing next is they're showing you, or talking about 2 special linear functions that produce straight line graphs. So notice that this graph above had a slant to it. It was angled, right? We're going to talk about straight line graphs next. And so that's where I'm going to pick up in our notes, and that's getting us to talk about vertical and horizontal lines. Oops. Here we go. All right. So the first one we're going to talk about is a vertical line. So I'm going to label this as a vertical line. Just as a reminder, your vertical lines are always in the form of x equals c, where that c is a constant. It's a number that would actually be plugged in. All right, and let's go through an example of that. So the example they give us in the textbook, so I can kind of follow along with it, is x equals 5. So when we're drawing a graph, and I'm going to set this up. So 1, 2, 3, 4, 5, 6. What's important when you're drawing a graph is that you always mark how many, what your scale is. So I drew 6 tick marks on the x-axis here. So I'm going to put this number 6 to say that every tick mark is 1, because it's kind of hard to do 1, 2, 3, 4, 5, and 6 and writing them underneath. It's going to get a little bit messy when we go to start graphing. So I'm just going to write the number 6 on the end of the x-axis to say that right there is 6 units. And then on the y-axis here, underneath I have -5 because I went 5 tick marks down. Going 5 tick marks up, so I'm going to write a 5 above. And I'm going 6 tick marks backwards on the x-axis, so I'm going to mark it with a -6. Do your best to keep those tick marks as equally spaced apart as possible. So our goal is to graph the equation x equals 5. Well, the equation x equals 5 means x is always equal to 5. So x equaling 5, and I'm going to do this in orange, is this point right here. That is the point of when x equals 5. And so the equation x equals 5 means x is always going to be 5. No matter what your value of y is, x is always 5. And so that is what creates this vertical line that goes through the x-axis at 5. So a vertical line is going to be in the form of x equals, and whatever that number is, that's telling you where you're going to draw that vertical line through the x-axis. It's going to go through that value on the x-axis, whatever c is. So this is x equals 5. Next, we have a horizontal line, and a horizontal line works similarly, but it's horizontal, so it's going in the other way, or the other direction. Oops, I'm just going to draw a line to partition this off. So horizontal line. So with these vertical and horizontal lines, you do not need to create an input-output table because they're straight like this, vertical or horizontal, because they have a constant value and they don't have any slope or slantedness to them. So you don't have to create an input-output value. So your horizontal line is going to be in the form of y equals c. The example that our textbook uses is y equals 4. So again, if we create a graph with our x and y axis, All right. So I have labeled it, and you might be wondering, well, why did you go to positive 4 units on the x-axis and negative 6 units on the other side of that? And it's just how many tick marks I could fit. I know I have this horizontal line of y equals 4, so I know that my y at least had to make it to positive 4, and I ended up going up until 5 on the positive y part of my y-axis. So know that there's no, like, technical or specific reason why I went the number of tick marks I did on all of my axes here. It was just how many I could fit. So graphing y equals 4, I'm going to go to positive 4 in the y-axis, which is right here. And then I'm just going to draw a horizontal line that goes through that value. Because y needs to always be equal to 4 with the way the equation is written. No matter what value of x is, y is always 4. It's this constant value of y equaling 4 the entire time, which creates this horizontal line.